In this video, we're going to introduce logs. Logs are the inverse of exponents. I like to think of it like this. The answer to a log is an exponent. You are given the connection between exponents and logs in your formula booklet. You are told that if a to the x equals b, this implies that x is equal to log a of b. Where a is greater than 0, you can't find a log or a negative base, and b is greater than 0, and a cannot equal 1. The logarithm tells us what the exponent is. Just like I said, the answer to a log is an exponent. So if we've got 2 to the power of 3, the base in both cases is 2. Our answer is 8. So we are basically asking 2 to the power of what gives us 8, and 2 to the power of 3 is equal to 8. So the logarithm answers the question. Let's go through some examples. Example 1, 3 to the power of x equals 81. In this case, I don't really need to use logs. What it's asking me is 3 to the power of what equals 81. Well, I already know that 3 to the power of 4 is equal to 81, so x is equal to 4. In the second one, 2 to the power of x equals 9. Well, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, so it is somewhere between 3 and 4, but I can't do it in my head, so I could write down log to the base 2, 9 equals x. I can now use my GDC to answer this. So I open my GDC, so I want the logs, so it's control 10 to the power of x, so I want log base 2, 9, press enter, so 2 to the power of 3.16993 will give me 9. Therefore, x is equal to 3.17 to 3 significant figures. Question 3. 4 to the power of x equals 100. So I can write that as log 4 100 equals x. So go back to my GDC. So I'll reopen my GDC, and this time I want to go to logs again. So control 10 to the power of x, and I want log 4 equals 100. Enter. So 4 to the power of 3.32 to 3 significant figures will give me 100. So x is equal to 3.32. So question 4, p to the power of x equals a 30. It doesn't actually want us to actually give a numerical answer, it just wants us to write it as a log. So we would write log p 30 equals x. Question 5, e to the power of x equals 7. So I just want to show you something. Log 7 is the same as log e to the 7, which equals x. Euler's number has a special way of writing its logs. It's ln instead of log to the base e. I sometimes find it easier to write log e because I can then understand what it is, but it's up to you. So e to the power of x equals 7. We would write log 7 equals x, and then if you work that out on a calculator, you would get the answer 1.95. So x is equal to 1.95. Question 6. Log to the base 4x equals 3. So I'll rewrite that as an exponent. So I get 4 cubed equals x. So 4 cubed is 64. So x is equal to 64. Log to the base 7x is equal to 3. Rewrite that as 7 cubed equals x. 7 cubed is 243, so x is equal to 243. Natural log x is equal to 5, so I'll rewrite that. Remember, it is base e, so it's e to the power of 5 equals x. So x equals e to the power of 5, and if you work that out on your calculator, you will get an answer of 148.4. So x equals 148.4. But in an exam, I would leave any answers involving e as e to the power of 5. That's a perfectly good answer. So that is an introduction to logs. Don't be overawed with logs, but the thing I want to emphasize more than anything, the answer to a log is an exponent.